First of all, welcome to 2023 Virtual Christmas Summit. Please don't unmute or interrupt the presenter, and feel free to put any questions or discussion in chat. As most of you know, we have the pleasure of having Jason Sisk of SFL Designs with us today presenting. And the name of the class is 3D Printing Tips and Tricks. With that, Jason, it's all yours.
All right, yeah, and definitely post any questions you've got. I'll try to get through the presentation here with some time so we can discuss later. But if you don't get your questions answered, meet me over in room 8 after the presentation, and I'll be there from for an hour after this one. So from whatever 7 to 8. Okay. Well, let's get started here. Let me go to 3D printing tips and tricks. Now, the one thing I want to preface here is this is just in my experience. This is what has seemed to work well for me. What I recommend or suggest for you may not necessarily be the case, and that's okay. Even from machine to machine, you're going to have variations. So we're going to kind of go through a few things. Number one, the printer setup, what upgrades you should be doing, what kind of material you should be using, the material calibration, which some of our earlier conversations here kind of leads me to believe that that's why a lot of you are here. Slicer selection, and then general discussion and Q&A. And again, I'll be available in room 8 after the presentation. I am a firm believer of teaching the DIY community how to fish rather than just giving them fish. I don't want to feed you guys. I want to teach you. I would rather you print your own stuff than to buy them from me. And I don't know if there's other vendors out there that have that same mentality, but that's the reason why I give away all of my designs. I give them away for free. You can download them all on my website or on Thingiverse for free. And I do that because I want to support the community. A little bit about me. I'm located in St. Clair. And let me move this because can't quite see. So I bought my first printer back in the spring of 18. So I've only been doing 3D printing for just a few years now. It was a kit from Folgertech. If you're familiar, it's an FT5R2. I bought they were about $500. I bought the second revision. Yeah, I don't know why. Maybe that's just when I was around at the time. That's what I bought. And my first print from the machine was absolutely terrible. I don't know about you guys, but my first experience was very rough. And I was like, oh, okay, whatever. So was my second and my third and my fourth print. They were all terrible. And it took me probably about 2 months to actually get the printer to print a decent part. But keep at it, and you're going to be able to get it. So if you're having troubles now, it's patience and calibrations and then testing. Lots and lots of testing. I've owned a few printers, maybe 30-ish. I really haven't kept track. I've done some resin printing and I didn't like it. It gave me headaches, so I got rid of it. And I didn't really have a need for it in this community. And then a little bit about my personal life. I've been married since 2007, and I've got 3 daughters, 13, 3, and 2. The 3 and 2-year-old are our foster girls, and we're hoping to adopt them later this year. I was baptized in 2005, and I've been serving in our church for many, many years. I was ordained as a deacon back in 2012, and then I moved to another church to serve in 2014, where I'm a leader and an elder over there as well. So I'm very involved in my church, the people around the church, whenever I'm not printing. And then I also met the man, Tom Betgeorge, and didn't really put 2 and 2 together that he's pretty short, but he's a really nice guy. So printer setup, we're going to talk about a few things. This is just kind of a bullet list here. We're going to calibrate. Really, we need to be calibrating our X, Y, Z, and E steps. That should be your very first thing you should do when you get a printer. other than unboxing it, powering it up, putting it together. Bed preparation, we're going to calibrate material temps, the extruder retractions. Is that it? Yep, I guess that's it. So let's go through the steps per millimeter and why this is important. And we're going to do this in two different, I'm going to kind of talk about a little bit from the Marlin side, but also from the clipper side. I didn't get into the bamboo side, and I don't really know that there's a need to, but if you have questions about it, I can answer it. So what are your current steps per millimeter? Well, if you don't know what that is, you can either go to your screen and the dial. Most of the time on these Ender 3s, you're going to see you've got a dial indicator, and you can narrow down to where these steps per millimeter are. And you're going to want to write these down. If you're using like Octopi or Face, some other communication to your printers, you can send an M503 code to the printer, and then you can actually get the details out of the printer from the echo command here, or the echo data that's coming out. So your steps, it's actually an N92 that'll tell you what your steps per millimeter are. Why is this important though? This is important because we have to make sure that whatever we're printing is actually the size that we want to print it. And there's two ways of thought about this. You can either set your calibration or set your distances based on the part you're printing, or you can set your distance on what the printer actually moves at. And the way that you could do this is you can either do it through I don't even have that up here yet. It's the next one. So we want to have this measurable value and then record the data. We're going to use the equation below to change our steps per millimeter. And I'm going to show you how we're going to actually obtain those steps. But if you want to write this equation down, it's fairly easy. It's your E-step value over your whatever your distance is, or that you're measuring, minus the actual distance that you measured, and then multiply that by 100. So this is the Marlin side. The clipper side's a little bit different. So let me see if this is the clipper side. So same kind of thing, but instead of steps per millimeter, clipper uses rotational distance. And this is the equation that they use for the rotational distance. You can also find, if you're using clipper, if you want to go to clipper, maybe you don't even know what clipper is. I don't know. But if you don't know what clipper is, it is another version of software or firmware rather that you can put on your printer, and then it uses your Raspberry Pi like an Octoprint or like a remote terminal, if you will, because that's kind of what Octoprint is, remote terminal, where it can control your printer. But Clipper helps you share the load of the resources of, here's what I need to tell the printer to do during the print process. And instead of doing it all on the motherboard for the printer itself, you can share that load with the Pi. So the Pi does a lot of the calculations and the user interface and handles all that stuff. But then the printer just does the next command. It does the next command. It does the next command. So it doesn't have to really worry about the main load. So ways that you can calibrate your steps per millimeter. And again, this is one of the most important things you need to do whenever you start your new printer, is you can use a ruler. You get yourself a Mitutoyo ruler. It's 150 millimeters. I've got one. I also have some digital calipers just to check what I'm actually printing is to the correct size. A lot of people will print that 20 millimeter cube. I don't think that's enough. You can do it if you have a set of digital calipers that can read out to 4 or 5 decimal places if you need that accuracy. If it's the stuff that I make and the stuff that I design, the tolerances can be tight, but they also can be a little bit loose. So for me, I want to make sure my printer is doing exactly what I tell it to do. If it's supposed to go 100 millimeters, it needs to go 100 millimeters. So I calibrate my machines to the actual distance they need to. One way to do that is if you look at this top right picture up here, this particular calibration piece is 100 millimeters by 100 millimeters by 50 millimeters tall. And this helps me get my precision much closer than using a 20 by 20 millimeter cube, just because it's more, there's more distance here, there's more room for error. So then I will use this and to get my printer the steps per millimeter into whatever spec I need to get them into. And I'll usually get this within probably plus or minus 0.5 millimeters, and then I'll call it good. But it's usually multiple times that I'll print this. So I don't just get it to that point once and say, okay, I'm done. I'll print that again and maybe one more time just to make sure that that is a correct measurement. So whenever you're doing these tests or these calibrations, a one and done is not the approach you should be using. You should be using a, let's do this 5 times, and if it's repeatable, then it's good. Oh, and I was going to talk about this too. So some people will use the ruler, some people will use these cubes or calibration devices. I prefer the calibration devices over just the ruler method. And what I mean by the ruler method is your printer, let's say it's a Cartesian printer or whatever. Okay, you start at 0, 0. And if you say, okay, I'm going to go 100 millimeters to the right, or I may even start at like 200 millimeters or whatever you can measure, it's whatever point you can measure at. You're going to tell it, okay, go 100 millimeters and then check it with a ruler. I don't find this as precise because I don't have good indicators on the moving parts to be able to take a good measurement. And I'm definitely not going to put a hard mark on my my rods on my X or Y axes just to have a measurement point on. So the ruler side I don't use for X, Y, and really Z either. You could use it for Z using moving the carriage up and down. I do that. I use that method only once, and that's just to level the carriage to the bed, and that's, or to the frame itself, and that's all I use it for. And on the Mega S's, they've got 2 home position switches, one on each side of the bed itself for the Z axis, and that's where that comes in play. If you only have one Z axis limit switch for the home position, then you really, the home's a home. You could try to get that slant out, but really that's going to come down to bed leveling, and we'll get to that in a minute. The other reason why you would want to use a ruler is for your extruder steps per millimeter. When you do the extruder, if you tell the machine, I want 100 millimeters of material to come through the hot end, you need to make sure it's really giving you 100 millimeters of material. You may be chasing your tail around trying to make sure that the flow, like if you look at the top of this cube, you see all those holes, the little pinholes all the way around, and this is terrible calibration of flow. And if you're not extruding the proper amount, you could be under extruding, or you could be over extruding. It could be saying, okay, I want 100 millimeters of material, and then it just gives you 105. Well, that's going to give you blobs and zits, and the appearance of the outside of the part's going to look like garbage. And then the PET G material, if you over extrude, you're going to end up bunching up the material on the tip of the nozzle, and then that's going to create a bunch of problems. You may end up having large globs of material that get dropped off from time to time, and by the time you get back to that position, it's already hard, and then you're going to end up jumping steps, and you're going to screw up the entire bed of whatever prints you got going on. So do a cold extrude on a Bowden tube. If you've got a direct drive machine, you can pull the hot end off, the actual throat of the hot end off, and just have the material come straight through the heatsink tube, and you just have to tell the machine that it's either hot or you're going to have to enable cold extrude. But what I like to do is on Bowden machines is I'll actually cut it right after the extruder where it goes into the Bowden tube. Take that Bowden tube off so it never gets to the hot end. Warm your machine up to the hot, whatever temperature you need to warm it to. Minimum is 175 for PETG in most cases. And then I would pull and I don't have pictures of this, I apologize. I would pull the filament through the end of the extruder, not the hot end, the extruder where the gears are, where it's actually pushing the material through the Bowden tube. I would cut it smooth, and then I would say, give me 100 millimeters of filament, and then I would measure that. If you're doing direct drive, you can do the same method. You would just have to cut it underneath below the heatsink and then measure from there. You can also mark lines, but I don't like that because my Sharpie, I don't have a fine point Sharpie, and just that difference of a millimeter width could really screw up a print. So I do a cut and then I measure. Hopefully that makes sense. If you got questions about that, put them in chat and I can address them. So moving on to glass versus PEI, and I don't want to start a fight in here in the Zoom room, but there's a lot of people love glass beds, and a lot of people love PEI sheets or that flexible magnetic build plates with PEI. You guys can decide what you think is going to be my guess, or what I actually like the best here. Glass beds are flat. For the most part, when you buy a glass bed, it's typically going to be flat. You're not going to have the dips in the middle. You're not going to have the edges have dips or anything like that. Glass beds, now the newer ones, they're starting to coat those with something. I don't know what they're coating them with to where PLA or PETG may stick to them a little bit better. If you're using glass, you may actually end up having to squish your material down a little bit closer to the bed, or you may also have to have a hotter temperature on the bed. Like a glass bed, whenever I was printing on glass, I would print at 90°C with PETG. On my PEI sheets or the magnetic PEI sheets, I print at 70. So I needed that much higher just to get stuff to stick to the glass. You may have to use glue, you may have to use hairspray or other types of adhesives. I try to get away from that. I try to get away from having to use anything on the bed just because it's a mess to have to clean up. I have had glass break off into the bottom portions of my parts. Whenever you go to take parts off of the bed, you usually have to use a scraper or a putty knife or something like that. Razor blade worked really well for me for most times until I cut chunks out of my fingers. And then you can swap out the glass beds pretty easily. Most of them aren't glued down. Most of them are going to be held down with binder clips or some other type of a clamp. Now, the PEI sheets or a removable sheet, and I say PEI sheets, I was a huge fan of the stick down PEI sheets from Gizmo Dorks. Loved them, absolutely loved them. Had a PETG always stuck to them, never had issues with that, never had issues with the material coming up. But the downside to that is it's not a flexible plate and you can't remove it and just pop the parts off. The PEI sheets, they can have different textures. You can get the rough or the rough surfaces, the smooth surfaces. You can even get them now with patterns. And I've got some of those here that I use. I've got a carbon fiber pattern that I use for PLA. I don't use it for PETG. And then most materials will bond to the plate without any adhesives. I don't know the last time I've used glue, hairspray. I can't remember it because I don't do it. Now, the downside to this is they're not as flat as glass. So whenever we go through I'm going to actually share with you guys my method of leveling a bed. And hopefully you all can get maybe even share some of your experiences with me with that, but maybe you can gain some knowledge from that or gain some something to help you out on leveling the bed, because that is important. But it's not as flat as glass. You may have dead spots in the center or a high spot in the center or off to the side, and you just have to deal with that, unfortunately. So yes, and also Barry mentions here that letting it cool down completely on glass works best. That is true also for the PEI and the PEI, the removable plates. If it's cooler, they pop off really nice. On my removable plates that I have, if it's still hot, they still do pop off, but sometimes you got to flex them a little bit more just to get them to pop off. And then I clean, the other thing I do is the glass beds, I would usually clean with a razor blade and then just some isopropyl alcohol. On my PEI sheets, I still clean them off with a razor blade with one of the little thin dual-sided blades, and I just run it down the plate. It seems to work great. And then I wash those with Dawn dish soap. It's very, very critical that when you're printing with PETG, that the build plate itself is clean. And I used to use isopropyl alcohol, but I've found that sometimes that doesn't get all of the oil residue from the plate. So I use Dawn dish soap, and that's been a stellar product since then. Yes, PETG, you can refrigerate it to help pop them off too. Good suggestion, John. All right, bed leveling. This is probably going to be the bulk of my presentation today, I think. Your bed leveling is going to start with a good structure. And what I mean by that is most beds nowadays, bed slingers, not the beds that are fixed, like this, the Cobra Max that's back here in my corner. That one does not have any springs, any bushings, nothing for the bed level. It is hard mounted. I can't adjust it. It is what it is. When you have those machines, they typically come with some type of a sensor, to a conductive sensor or non-conductive sensor, like a BL Touch or a CR Touch or something of that nature that will actually come down and measure the bed before you start a print. So I was a big fan of these big springs. They worked great until they didn't. I ended up moving over to the bushings. And I moved to the bushings because what I found was when I compressed those springs over time, I didn't lock the nut. I didn't put another nut behind the adjustment screw for the bed levels. And over time, the loose ones would come even looser, and the tight ones would most of the time remain tight. I went to the bushings, and I can get more throw on my on squishing the bed down, and then I can also that also creates more pressure on the threads on the screw that I adjust the bed height with underneath the bed, and that helps them from not backing off. So I don't have to use a lock nut on the bottom side of them. The hot end, whenever you do your leveling process, it's very critical to get your hot end and your bed up to the temperatures that you're going to be printing at. So if you're printing PETG on a glass bed, you might be 80, 90 C, get that up to temperature. Your nozzle temperature, we'll talk about it, but can be anywhere from 230 to 260. And it just depends on how fast you're going, but we'll get into that. What I do is I start by moving my hot end out 20 millimeters in the X and Y direction. And then I'll use a shim or a piece of paper. I like the shims better than the paper because as you start, homing down on this paper, I think, and this is just a theory of mine, I think the paper ends up weakening, and then you get a kind of a flatter spot there, and it screws with a lot of different things. So I use a shim, and I use a 0.1 millimeter shim, and I will bring the bed down to that shim, and then, or down to 0 in most cases, and then I will adjust the bed height to where that shim is being touched by the nozzle, but can be pulled out from the nozzle. So I give it a little bit of pressure. I don't get it to where it's tight, and I don't get it to where it barely touches. I get a little bit of pressure on that shim to where I can pull it out, and push it back in. And it usually will just go in, it'll take a little bit of force to push it back under that nozzle, but that to me has been the best starting point. And I say starting point, I'll get to in just a minute. Let's see. Oh, there's the bushings. So there are the silicone bushings that I was talking about. You can get those on Amazon. I've got them on all my machines, all my Anycubic machines that have the movable beds. Here's the leveling process that I go through. The hot end bed needs to be up to temperatures. We're going to move the hot end out 20 millimeters. We're going to use our shim. And this is the direction. And I'll try to go through this slowly, but we'll see. So first, you're going to move from this left front position to the right front position. So once you level this point right here, and that means bringing your nozzle down to 0, and then adjusting your bed to, like I talked about with the shim, getting that shim to where it grabs, but doesn't, you can still pull it in and out of there. Then I will move over to the front right, and I'll do the same process. I'll get that shim, level it. Okay, the next step that I do, I go back. Yes, Dave, auto leveling would be the machine doing itself, and I'll talk about that in a minute. Remind me after we're done with this, and I'll mention the mesh bed leveling because I think that's important too. This is all manual bed leveling. That's what I'm talking about here is manual bed leveling. You don't need a BL Touch. And I had one installed on, and I don't know if Ben, if you knew about this or not, I had one installed on my Mega P machine, and I disabled it because I didn't find it. I found that it was actually more inaccurate than me doing manual leveling, and I never went back to auto sensors on those machines at all. So we start in this front left, we go to the front right, then we go back to the front or the front left. And re-level it again. Okay. Then I go back to the front right and I re-level again. And if you're wondering what we do next, we go back to the front left and we do it again. And then we go back to the front right and we do it again. The reason why I do this many times, and I may do this 5 or 10 times, is I want that front level with the bed. Or with the hot end. This allows me to get a good consistent left to right balance to where I do a lot of my movements here, and then whenever I move to the backside, it allows me to not have to make such a drastic movement. So then I go from the front right to the back right, and then I do the same process, but I go front to back. And I'll do this a few times, front to back, front to back. This allows, so whenever you make adjustments on your bed, you need to be aware of what change it's going to make. If I adjust this front right corner, you don't just affect the front right corner. You're going to affect the front left and the rear right corners, even a minor change. So usually if I have to make a small adjustment on the fly, let's say I got to turn the bed down a quarter of a degree or so, quarter turn. I may do a quarter turn on that front right, but I also may do maybe an eighth of a turn on the front left, just so I can try to balance it. And then I'll watch the print and make sure that that side is actually printing properly. So from the back, you go to the front, same process. You're going to do that a few times before you move on to the backside, continuing the backside back here. You need to come back and do the front again. So you're going to go from this front right, you're going to go to the front left. Then you go from the left to the right, and you're going to do this process. You're going to go in this triangular pattern a few times because I want to get these 3 points into the same kind of environment area. Okay, then once we're done with that, then we're going to go to the back. And we're going to do the same thing. We're going to go back side to side, side to side, side to side. And again, the reason why I do this is because it's going to make the whole process a little bit finer. You're going to start making adjustments instead of having to do 2 or 3 turns or even a half a turn. You're going to start doing an eighth or a 16th of a turn. So you do the back, then you're going to come to the front, and then you're going to go front to back, front to back. You can always add in steps here to go front to back and then right to left, front to back, left to right, whatever you want to do. Once you're good with this front to back, you can go back and check this right side if you want to, or you can play ring around the rosy. And that's typically what I will do is once I get a good feel that I've got this pretty much in, now I'll go around the plate. And I will do this probably 4 or 5 times, maybe more, just to make sure that I've got this nice and good. Because sometimes if you make this adjustment here, it's done screwed this one up. So by going around in a circle there, you're going to make sure you capture it and get it nice and flat. And if you noticed, I never once touched or measured the center of the bed. Almost every machine that I've seen so far has never had adjustability in the center of the bed. Maybe I had a Tronxy quite a while back. It might have had a set screw in the middle, but I don't think it did. But almost all of the machines that I've dealt with, it's either for the 4 corners or that Folger Tech, or even the bigger machines, you might have 3 on each side. So you're going to have a middle on each side. Now, if you have any questions about this, go ahead and pipe up now. If you want to unmute yourself and ask a question, that's fine too. If not, I'm going to move on.
Do you level after every time you do a piece, or
No,
just every time you
no.
move the?
And that's a great question. So when do you level? If you have a sensor like mesh bed leveling that we can talk about now if you want, you can. I would probably level on my bamboo machines back here. I level before every print. And the mesh bed leveling, what it'll do is it'll go down and probe, usually 3 in the front, do like a 3x4. So it'll get you get quite a few points in there. And then it will create a grid that will tell you, okay, here's how warped the bed is. I have a machine that's got a duet in it, and it will actually graph out what that planer is. I think Clipper has it too, and you can graph that out and then just tweak it here and there. But usually I don't mess with leveling the bed until one of 2 things happen. Either I have to change a nozzle. Anytime you do any type of a height adjustment on your machine, your hot end, you need to re-level your bed. So if you change a nozzle, if you have to repair something and something's going to shift on the hot end, or if you have to repair the bed, definitely level that bed before you start printing. And then the other case I would do it is if after a while I notice that I'm relatively squished on one corner over time because maybe the set screw came loose over printing, then I would make a special case to level the bed or re-level it then. But in most cases for me, I mean, I was running like thousands of hours on my printers, and I would probably go maybe a month, maybe 2 before I had to level the bed. And it usually because I changed the nozzle. And I went through a lot of brass nozzles. I didn't do the hardened steel nozzles, and I'll explain why, but I preferred the brass, and it was just a commodity. I just had to replace them. Mesh bed leveling, yeah, mesh bed leveling is good, but I always like to have a lot of points. So on my 300 by 300 machines, I would actually do about 49 points. So I do 7x7. I guess did I do the math right? But it usually was 49 points, and it took about 10 minutes to do. But for me, if I'm filling that whole bed, I want to make sure that I know the bed's not flat. I know that for a fact. So I want to make sure that whenever the head comes down, when I use mesh bed leveling, the hot end will adjust to those features that weren't level, and it'll keep everything printed kind of proper. All right, moving on to why we want a bed level. This is not mine. This is from Billy Rubin. It's on, if you want to look it up, there's the URL, but it's a Reddit. And he made a good graphic here, and I stole it because I thought it looked really good. But this is what you want to be shooting for, is this perfect. And this is kind of subjective of what is perfect, because if you don't have your flow set properly, if you don't calibrate your E-steps properly, you're never going to get to this point, or you're going to be way over extruded. You're going to get ridges. You're going to get elephant's foot. There's a lot of different factors in there, but your goal here is a completely flat first layer with no ridges and no gaps. And by ridges, what I mean is when each extrusion layer comes in, if you're over extruding or if you're too close to the bed, you'll actually have the layers start, instead of laying nice and even side by side, they'll start creating overlap and getting some ridges in between them. And you can really feel it on the top surface if it's your extrusion, or if you're, if you see it on your first layer, you'll know if it's not extrusion by your top layer of your print. If your top layer is nice and flat and good and smooth, then you're probably printing too close to your bed. If your top layer has ridges in it, then you probably have either an over extrusion, or you don't have your flow calibrated correctly. And then if there's gaps in both, well, you're either too far from your bed, or you have a extrusion flow issue. So this is a good graphic. Take a screenshot if you want, or go look it up from Billy. And there's more information here. I just chopped out the good picture that I wanted to use here. So printer upgrades, usually, and I talked to Ben about this in the past, I had a process on my Anycubic machines, and I upgraded things in a certain order. So I would usually upgrade, the build plate was first. I liked the Ally Express PEI magnetic plates. I've got filament plates as well. They are really nice, like Ben mentions, but they're really expensive. So a filament plate for the Anycubic is about $65. If you order in bulk, which is what I typically did, 10 plates at a time, then I got them a little bit cheaper. I think maybe 40 or 45. If you buy them from Ally Express, they're about $10, $15 a piece. All of the Bamboo machines back here, I bought the textured plates from Bamboo, and then I quickly realized they're junk and I threw them in the trash. I've been running these Ally Express plates at $13 a piece on all my machines, and they're rock solid. They're great. So build plate is a very good upgrade. Stiffer springs and bushings, like I mentioned earlier. You can go to the geared extruder. A lot of people want to go to all metal extruders. I am not as convinced that that is a good upgrade. I mentioned the Titan extruder here. It uses plastic gears. And the Mega S and Mega P machines that I'm accustomed to working with, and the Mega X, they all come with the Titan extruders. And I've really had good luck with them. Yes, they do wear out over time, but I'm talking like 2,000 hours of printing, and they finally wear out. And it's usually the bearings that wear out, not the plastic gears. So don't shy away from plastic gears. Just know how to use them properly. And also here, this Creality, this is not, this is metal gears that they're using here, but I don't like these. I like the going from a larger gear to a smaller gear for a different gear ratio, and it helps with my steps per millimeter, and it also helps, I think it helps with the back feeding, the back pressure of the system. I can get more force, more torque using the bigger gears than I can with these smaller geared all metal extruders. All metal hot ends, Slice Engineering makes a really great hot end. E3D is what I typically used on my machines, the V6 E3D hot end. It gave me enough temperature and enough flow. Motherboards, you can do the Big Tree Tech. That I have a couple Duet boards. The MKS board obviously is what I believe comes with. No, actually it doesn't. That's not the Anycubic. The MKS is what came with my Folger Tech board, and it's okay. The MKS board uses, and I think even Smoothie board uses Marlin, where you can Duet uses its own thing, but Big Tree Tech, you can actually download the Clipper firmware onto it and use it instead. Hard nozzles. I'm not a fan of hard nozzles. The reason why I'm not a fan of hard nozzles is the temperature that you need to print at with brass may be, let's say 240 is what I was typically printing PETG with. When I go to a hard nozzle, now I have to have a higher temperature. And on a Bowden system, if you don't replace the hot end, they call these all metal hot ends. Sometimes the ones on Amazon, they're not really all metal hot ends. And I don't get into this, but if you come talk to me after after whatever in room 8 later today, we can talk about hot ends. But basically, it comes down to the Bowden tube coming almost all the way down to the heater block on a stock system. On the Slice Engineering and the E3D, that Bowden tube actually stays up above the heatsink. So the Bowden tube itself doesn't see the hot temperatures, the 240s, the 250s, which is what most Bowden tubes can sustain, and that's it. Even the Capricorn tubes, they're rated around 240. So if you're printing PETG, I'd get rid of the quote all metal hot ends where the Bowden tube goes all the way down to the heat block. It's not worth it. You mentioned, let's see here, question about better to get an Ender 3 and do upgrades or a Bamboo X1 out of the gate. That's a preference thing. If you like to tinker with stuff, get a Creality and play and struggle until you get it right. If you like to just unbox something and make it work, get a Bamboo. That's the best way I can tell you. It's Apple and Android. Apple, you can just unbox it and use it. Android, you've got customizations. You can do things with it. You can upgrade it. You could spend some money. I don't know. To me, I use Bamboo now. Bed level sensors, we kind of talked about that. BL Touch, CR Touch. I'm not a fan of the bed level sensors from the Creality Anycubic stuff. I just manually level it. It's been working great for me. You do cameras so you can watch it print. Part cooling fans. That's pretty key for PLA. When you're running a standard printer with PETG, you typically won't use a part cooling fan at all. The Bamboos do use a part cooling fan, but I think that's just because they're quite a bit faster and they need that material to cool down before it puts the next layer down. Some of these machines you can upgrade with lasers and do laser etching or cutting. I personally have not. I do have a Mega P, which was supposed to come with a laser, but I bought it at a discount and didn't come with it, and I haven't messed with it. Material selection. We're going to be either ABS, PETG, or ASA. ASA is relatively new, and I considered moving over to it, but it's a little bit more expensive than PETG. And what you gain out of it for me and the people that I print for, it's not worth the extra money because I'd have to raise my prices. So here's kind of a general, this kind of, I don't know if this graphic is really that great, but it came from that filament to print. And ABS is not waterproof. ABS is hard to print with, and it also, you don't have to have an enclosure, but it does have some gassing whenever you print it, and it is toxic. So within moderation, you're probably going to be okay. Don't stand over top of it and breathe it for hours. Use your head on that one. But PETG is kind of a best of both worlds. It prints like PLA in the sense of it's easier to print sometimes, but it doesn't require a lot of the heat and some of the problems that ABS causes whenever you print with that. ABS, you need an enclosure. You should have an enclosure. stay away from vents. You don't even want to walk by a printer that's running ABS that's exposed. The temperature difference could end up pulling your part right off the bed. ASA is, again, it's UV resistant. It has a lot of the same properties that PETG has, but it's a little bit more expensive. It is easier to machine. Whenever you start looking at PETG, don't even bother. Just print with ABS or ASA if you're going to need to machine it down. Flexibility wise, I think ASA and PETG are very similar. And UV resistant, ASA is more UV resistance, but PETG is fine for our hobby. I've got clips that have been outside for many, many years that are just fine. So with PETG, the material calibration, we're just going to focus on PETG. The temperature range is 230 to 260. And I put a range in there because it depends on how fast you're printing. Your printing speeds really can be anywhere from 50 to even 500 on some of these machines, but you have to be able to have the proper flow. And when you start talking flow, it's if you want to print faster, like I was printing my machines at the Anycubic machines at 100 millimeters a second. I was pushing 240, 245 on the range here. These Bamboo machines are printing close to 300 millimeters a second, and they're running at 250 C. So the faster you print, the hotter you need to print. There's a downside to this too, because if you don't have your flow calibrated correctly and you don't have your retraction settings calibrated correctly, you're going to see a ton of stringing, or you're going to have zits, or you're going to have build up over time of your print, and then it's going to start dropping filament, and then it's going to be a mess. So going through the process of calibrating your flow, your linear advance or your pressure advance, and Bamboo uses pressure advance as well, is very, very critical. This is the site that 3D Maker Reengineering or 3dmakerengineering.com. They've got a good flow rate calibration. However, I don't use that test procedure for my wall calculation. What I try to do is to get a nice flat top surface, and then that's my flow. So if you get a nice good flat surface on the top and there's no gaps in between your extrusion lines, then your wall thickness should be pretty close, pretty on point. You may have to make a couple adjustments here and there, but you can use that to close the gaps, to make your prints not absorb as much water. Retraction for a direct drive will typically be 0 to 2 millimeters. And if you have PETG material, you may have to retract a little bit more. On my Bowden machines, I think I was up to 7 or 7.5 on retraction. And unfortunately, this is where the hard part comes in. If you want good prints, you've got to spend the time calibrating your flow, calibrating your retraction, calibrating your temperatures and your speeds. You may have to spend a day or two or even more, maybe a week, going through this process to get your prints looking decent or to get that stringing from happening. What I have found in my years of printing is I go through a process. I usually stick to one temperature, which is about 240. Sometimes I'll go to 250. But with PETG, the lower your temperature, the less stringing you're going to have. But also, the lower your temperature, the less bonding you're going to have from layer to layer. So you really want a higher temperature so your material bonds with the previous layer, making it very strong. But when you have a higher temperature, you're going to have more stringing. It's like you're gonna whack your brain up against a wall trying to figure this stuff out. But that's where the testing comes in. So what I would recommend is set your printer to one temperature. Let's say you're gonna go with 240, which is, if you're in the 50 to 100 millimeters a second range, that's probably a good starting point, is 240 for most materials. I primarily use Hatchbox. There's other good materials out there. I usually don't try to get cheap. because a lot of my stuff is going to go out in other people's shows, and I don't want cheap. I want something that I know is going to work and give a good finish. So I used about 240 on my Anycubics, and then I start with my retraction. And I usually start low. So I may start at 5 millimeters on a Bowden machine, or I may
Excuse me, Jason, 10 minutes.
Okay, yep, thank you. And I made a direct drive. I may start it at 0 and just say, okay, no retraction. See where I'm at. I'll do this cube test that's down here, and then I will get it to where, well, I'll go through that process, print it. Let's see what it looks like. If I got a bunch of stringing, okay, I might raise it a millimeter or a half a millimeter, and then I print it, and then I get that. Okay, I'll go through that process until I get almost no stringing. But what I'm looking for really is I'm looking for under extrusion at that point. Once I get to the point where I'm under extruding or I'm having gaps on a restart, then I'm like, okay, that's my threshold. Then I can start bringing it back little by little. Maybe instead of increasing by half a millimeter, I decrease by 0.25 millimeters or 0.1 millimeter. So I just try to find that sweet spot. And again, it's going to take time. One of these prints may take 20 or 30 minutes long. Get your values, make your changes, do it, and go through the process. What I would discourage you from doing is making more than one change at a time. Leave your temperature the same. Leave your speed the same. Leave your retraction speed the same. Leave everything else the same. Just change retraction distance. See if that works. Okay, your retraction speed, you may have to adjust 30 millimeters or 40 millimeters a second. You go through the test, do one temperature, do your retraction distance all through that test. Find a good point there. Get a good retraction distance. Now go change your retraction speed. Go through the same test process. Don't change anything else. Just change your retraction speed. And go through that test procedure over and over and over until you get a good print. And I know you're going to waste material. I'm sorry about that. That is something that I've learned through the years, that you're just going to go through material. Linear advance and then pressure advance. If you're doing linear advance, go look it up on the Marlin's website. If you're using Marlin, if you're using Clipper or Bamboo, take a look at pressure advance. And you can even look at the attenuation settings for what do they call that? I'm trying to think of the name. It'll come to me. The reason why we want to do this is in the corners. So as you can see here, in this circled area here, there's some gaps in the corners. But what happens is whenever your normal speed is 20, and then you speed up, you're going to get some, you're going to stretch that material. And then whenever you slow back down, you're going to bulge it back up. So getting a good K factor is what it's called. Getting a good K factor in here to get this to where it's as straight and smooth as possible will help a good print and will help your corners from not having to break apart. And I had this issue in the past. Hang on a second. So when I designed these roof mount clips, they would always break here in the corners because my K factors were not set right. And I wasn't getting good bonding in these corners. So now, whenever you push these down, since I have that calibration done, these corners don't start separating. They don't delaminate. And that is important. That's the reason why this is so important to do this linear advance and the pressure advance. So here's some recommended print settings for you guys. 25% infill is what I use. You can use grid. I don't like grid because it goes over itself. And I don't like any type of infill that touches itself when it's infilling. So I use honeycomb. You can use gyroid, but I never had good luck for that. But everybody's got their own little flavor they like. I use honeycomb. For most prints, you can print at 0.2 millimeter layer height. Nobody's really going to see the detail. Now, if you're printing something that has details, then you're going to want to do lower. At least a millimeter thickness for walls on top and bottom. So if you're using a different nozzle size, as long as you have a millimeter thick wall, you'll be fine. And then I do 6 top and bottom layers. but it's two-part, mainly for the structure because it's going to be thicker at 1.2 millimeters, but also for looks on the top layer because I don't want any holes or anything like that. Supports, I want you guys to know I hate supports. I absolutely despise supports. I don't like them at all. I try not to use them. I try to make designs that don't have supports. But if you have to use them, here's some general settings. Take a screenshot if you want. These have worked out really well for me. And the only thing I'll mention here is this top Z contact distance. I've moved to a 0.2 instead of 0.25 on these bamboo machines, but you can still use a 0.25. All right, moving on here. Slicer, there's a bunch out there. You can do Cura, which is, I don't like. Prusa is probably my favorite, other than the bamboo, which is Orca. And
Jason, you're at the 5-minute mark.
Yep, thanks, Paul. I only have a couple more slides, so actually I think we're almost done. I think this actually worked out well. I prefer Prusa. I think makes better prints, but there are other slicers out there. Cura is probably the more popular one because of the Creality printers. And I don't know, I just like Prusa better. So last thing, there's 4 stages of owning a 3D printer. Hell yeah, it's fixed. Sweet. And I'll print it again. What was that noise? I don't know. I hate these. I have said that many times to my printers. I hate these things. I'd never want to print again. Any questions? I know we kind of went through the last couple parts rather quickly. Again, I'll be available for the next hour in room 8 if anybody wants to chit chat or just see what I've got going on. I do have some stuff I want to show you guys too if you're interested. I got a new product that I'm launching, and I was going to reveal it there.
You
You're
said
in
to
the
mention about
active system.
self-leveling, Jason.
What's that?
You said to mention about the self-leveling if you didn't touch
Yeah.
anything on it.
Well, I did. So I kind of talked about
sorry.
it. That's the mesh bed leveling. If you have it enabled in your printer, you can use it. It's good as long as you are willing to accept it for its flaws as well.
Okay. All right.
So,
Thank you.
Hey, Jason, thanks for the class. And like you said, people can go over in the other room. Also, make sure these vendors have all taken time out of their Saturday. There are discount codes that I just put in the chat window. Feel free to go over there and take advantage of the discounts.